If you want to learn quick and easy ways to solve math problems, please like and subscribe to my channel. Our learning target for today, at the end of the lesson, you are expected to illustrate expressions with rational exponents and simplify it. Let us analyze these images first. What are the similarities and differences of these characters? They have weakness. We all have weakness too. Gai Sensei in Naruto has no genjutsu. The weakness of Superman is kryptonite. Mobility is the weakness of Nick Vujicic. And for Einstein, even though that he is a genius, he has many shortcomings. They become great because they focus on their strengths. Focus on your strength. It is your special gift from our great God, our Creator. He gave it to you to fulfill your mission He assigned you, and only you can fulfill it. We also realize the importance of our mindset, our thought, because there is a saying that, keep your thoughts positive, because your thoughts become your words. Keep your words positive, because your words become your behavior. Keep your behavior positive, because your behavior become your habits. Keep your habits positive, because your habits become your values. Keep your values positive, because your values become your destiny. Hence, our destiny starts with what we want to become. Do you know that not only people, animals, plants, and other created things possess similar and dissimilar properties, but numbers also possess unique characteristics? Let me give you examples. X, y squared, and z raised to the power of 1/2. What are the differences and similarities of these expressions? Of course, x has a base of x and an exponent of 1, while y squared has a base of y and an exponent of 2, and z raised to the power of 1/2 has a base of z and an exponent of 1/2. All of them are algebraic expressions, and all of them have letter bases. Both x and y have whole number exponents, while z has a fractional exponent. Expressions like x were already discussed in your previous level. Now, we will focus on the expressions related to y and z. Let's start our discussion with the expression with an exponent of a fraction. What do we call these expressions? Do you have any idea? Instead of variables or letters, can we have number as our base? Can you give me examples similar to expression with an exponent of a fraction? Please write 5 examples in your math notebook. In an expression with irrational exponents, there are 2 parts that we need to look into. Base, especially when it is numeric, and exponent. If the base is numeric, then it can be a prime number or a composite number. If it is prime, then you are safe. If it is composite, then you need to be vigilant, because it can be expressed as a power. What do I mean with this? Let me give you an example. 8 raised to the power of 1/3. 8 as a base can be expressed as a power of 2. So 8 becomes 2 raised to the power of 3. Aside from 8, there are limitless numbers that can be expressed in the power of 2, like 16 becomes 2 raised to the power of 4. 32 becomes 2 raised to the power of 5. And 64 becomes 2 raised to the power of 6. Other numbers can be expressed in a power of 3, like 9 becomes 3 raised to the power of 2, 27 becomes 3 raised to the power of 3, and 81 becomes 3 raised to the power of 4. Other numbers can be expressed in a power of 4, like 16 becomes 4 raised to the power of 2, 64 becomes 4 raised to the power of 3, and 256 becomes 4 raised to the power of 4. Other numbers can be expressed in a power of 5, 6, 7, and so on. So be vigilant with these numbers. Focusing our attention with the exponents, we must make sure that the fractional exponent in an expression with rational exponents should be expressed in simplest form. In the example we cited earlier, 8 raised to the power of 1/3,
our exponent here, which is 1/3, is the simplest form. If not, then we need to simplify it. Example, 5 raised to the power of 2 over 6 should be expressed as 5 raised to the power of 1/3. 13 raised to the power of 10 over 16 can be expressed as 13 raised to the power of 5 over 8. Now, a bit difficult if the base is composite and the exponent is not simplified. Example, 125 raised to the power of 4/6. Because you need to express the base as a power and simplify the exponent, so in this case, 125 can be expressed as 5 raised to the power of 3. And the exponent 4 over 6 can be reduced to 2/3. So the expression now becomes quantity 5 raised to the power of 3 raised to the power of 2/3, resulting further to 5 raised to the power of 6 over 3. So 6 can be divided by 2, so it becomes 5 raised to the power of 2, and lastly can be expressed as 25. In the example 125 raised to the power of 4/6 becomes 25, we can conclude that expressions with rational exponent 125 raised to the power of 4/6 denotes a real number, meaning it can be simply expressed as 25. Try answering the following questions in your math notebook. Number 1. When can we say that an expression with rational exponents denotes or represents a real number? Number 2. What are examples of real number? And number 3, enumerate the laws of integral exponents. To sum up what we had today, we were able to familiarize ourselves with expressions with rational exponents, its parts, and when the expression denote a real number.